Welcome to Mastering Solutions. In this, we're not asked to draw the ray diagram for this diverging mirror, but we're calculating the image position and the height. And so to do that, we're going to use the thin lens equation. Even though we're dealing with a mirror, the thin lens equation works the same and allows us to calculate the image position. We're told that the power of a lens or a mirror is equal to 1 over the focal length. And since we have a diverging mirror, this will be negative, like it said in the question. That is also equal to 1 over the image position plus 1 over the object position. We're just going to use this section, of course, and we're trying to isolate the image position. So let's minus over 1 over the object position. So 1 over s prime is equal to 1 over f minus 1 over s. So when we now plug that in, we get 1 over the negative 0.25 meters. It does need to be in meters for the equation to work correctly. And then we're going to minus from that 1 over the object position, which is 0.15 meters. So that's going to give us 1 over negative 0.25 minus 1 over 0.15 gives us negative 10.67 diopters. Negative 10.67 diopters. If we take the inverse of a diopter, that will give us meters. So we have negative 1, 2, so negative 9.4. So we have negative 9.4, if we round it, for our answer for the image position. So if we have a negative on the image position, that means it's a virtual image and will be and a virtual image means that it's on the same side of the lens as the object. Now with a diverging mirror, we always are going to get a virtual image. So it's also going to be upright, which you'll see with the second part for the height. To figure out the height, we're going to use the magnification equation. So m for magnification is equal to the image height over the object height, which is also equal to a negative image position over object position. And so if we just take this section of the equation, we're trying to isolate this. Let's multiply both sides of the equation by the object height. So the image height is equal to the object height multiplied by a negative image distance over object distance. So we have the object height, we're told, is 3 centimeters tall. Let's do it this way. 3 times 10 to the negative 2 meters. And then we have a negative image distance, which we said was a negative 9.4 times 10 to the negative 2 meters. I've mentioned it on several of the last problems, but remember, this negative comes from the equation. This one comes from the answer of the image distance. And so if you have a negative here, it is very important to put it in. Otherwise, you can easily trip yourself up and get the answer wrong just because of the negative being different than what it should be. And then the object distance is a 0.15 meters. So we have 3 times 10 to the negative 2 multiplied by a negative 9.4 times 10 to the negative 2. And that's divided by 0.15. So that gives us, in meters, and we put that in centimeters, we have 1.88 centimeters. And that was positive. And so positive on the height means it's upright. If it was negative, that would mean that it's inverted. But we always, with a virtual image, it will always be upright. And with a real image, it'll always be inverted. So here are your answers for the image distance and the image height. And it is a virtual upright image.